Let me introduce the use cases. So one important thing that I wanted to mention was that most of the use cases at on.lab are driven by partners, and most of the use cases are completely partner-driven as well. So there are some teams where we don't have anybody from on.lab, but the partners working in conjunction with the team here. So what we are doing next, so as you know, Thomas already did the demo live, and to get all our blood pressures up even more, we are going to do the next 4 demos live as well. Hopefully everything works. If it doesn't, we will move on, but the demos will be running on the lunch floor through lunch. So and we will table the questions till lunch just in the interest of time. So feel free during lunch to walk around and then get to know these use cases and the people who develop them up close and personal. So having said that, let me hand over to Tom.
Great, thanks, Prajakta. So I'm honored to be part of this team. These guys were up late last night, I know, and they've been up, for many times. Sorry about this noise. So I've been sort of on this project, and of course, multi-layer packet optical is one of my favorite, basically, use cases. Tom Anxious brought this to the table. He mentioned how multi-layer basically networks are complex, and so we wanted to sort of demonstrate that. So my teammates and I, I'm going to introduce the use case, and my teammates will demonstrate, some of what we have done and what we can do, and then I come back and maybe summarize, the capabilities and possibly, where we are going from here. So today, so I will demonstrate basically how SDN and ONOS can help address the challenges of managing multi-layer service provider networks. Earlier, my colleague, I guess, Thomas also showed the single layer, what you had seen there. So we are sort of, going to show you how we are introducing also another layer, which is the optical layer for this demo purposes. As you know, service providers are complex. Service providers' networks are complex and in nature, and obviously, they are managed independently. For packet layer, we have a separate team, and optical layer has its own team. And as the result of this independent management, some when you want to make bandwidth on demand to the optical layer these days are very difficult, and it takes days, sometimes months, to be able to introduce new service or add capacity at the especially the optical layer. So therefore, and of course, because of that, we have to over-provision both at the packet layer and optical layer. And of course, when anomalies happens, because of that, in case there's a truck road that runs over the fiber, etc., there has to be a lot of redundancy both at the packet layer as well as the optical layer. So with that, and the other aspects of it, has to do with lack of agility and significant capex and opex overhead that we are sort of dealing with today. And so that's the problem that we were given at the beginning when Tom Anxious brought this use case. We wanted to solve that. So we wanted to show the benefits of converged packet and optical control networks, and with that, we wanted to reduce the over-provisioning of the resources with the converged protocol. That's what we are going to hopefully to demo to you guys. We wanted to have the ability to have a fast allocation of bandwidth, showing you an on-demand ability to either when there is a reroute need required because of failures, or when customer make on-demand capacity. So converged, really SDN control plane for packet and optical can sort of address some of these issues that we've been discussing all this morning and etc. So with the converge, of course, SDN network, we also rapid recovery from transport failure. We talked about that as well, and service provision agility. That's what we are going to also see if we can show you that. So let me hand this over to my colleague. While proceed, he's going to set up for the demo and all of that. But our goal today is to show you, that we can provision on demand, as well as, we should be able to basically reroute around failures. And I'll come back and maybe talk about a little bit more, where we are going, with the liquid.
Hello everyone. So I just want to, before getting to the demo, I just want to show how the topology looks like. So what we have is ONOS having control on both packet and optical nodes. So the packet nodes we are emulating using OVS, and optical nodes we are using Link OE, and we communicate using OpenFlow protocols. So for Link OE, we use some of the experimental extensions that's been proposed in 1.5. So the idea is that we have hosts which are part of both data centers, and when there is a request which can come from a bandwidth calendaring app for a GUI or a REST call, that would trigger ONOS to set up optical circuits, which in turn would let the discovery of those IP links. And what then I would like to do is introduce some failures, and that should be picked up by ONOS, and there should be a new route that should be computed, and hopefully there should be no packet loss between those two data centers. So let me quickly get to the demo. Okay, so what you see here is I have a topology of both packet and optical nodes, and it's distributed across two instances. So you can see some instances on the blue one and some instance on the brown one. And I can get to the multi-layer view, and I can show there are some nodes which are on some of the optical nodes which are on 1.2, and these and some of the packet and optical nodes are on 1.1. So now what I'll do is I'll try to, like I said, I'll try to set up a connection between West Coast to East Coast. So we have two hosts. So I'll try to create a connection between these 2 points, and that should, now as you see that there wasn't a packet link before, and now you have a packet link. And if you go to the details of how this is realized, you can see the packet link is realized through how it's traversing through the optical layer. And if I go back and look at, if I try to ping the traffic, I should be able to see the traffic flow, and I can also look at if I go, I can also look at how much traffic is going between those two nodes. Now let me try to break a circuit at this location where I want to break the circuit that's, I want to break the link that's over here. So what you should see is that the flows over on this link should get rerouted. So for that, let me go back. I can say which switch, and I can ask. So what you should see is that that link has disappeared, and those two flows are now on the new path. And if you look at the packet loss, pretty much there's no packet loss as such. Yes.
What's a packet link?
What's a packet link? As in, it's just like a logical link.
Is it a tunnel?
No, it's not a tunnel. It's just an IP link. I mean, it's like a logical link, just an IP traffic. So you can look at, like, if you are pinging to host, if there is a pipe that's getting created.
State along the path.
That's right.
Okay.
How do you realize your packet loss? Do you have pre-established primary backup?
No. So right now we are rerouting. So there's always one path, and if there is a failure, we recompute the path. So so I can also I can bring down this active link itself, and you can see that it should go back to the original link. It didn't happen. It rerouted through some other link. Yeah, it rerouted to a very zigzag fashion, but it rerouted that link. So, like I said, we also develop a calendaring application using which you could submit the request. We use REST APIs to make the request. I'm sorry, you have a
Just one
question?
question. Can you go back to the previous? So, what did you use to calculate the new path?
So we're just using the shortest path, like how Tom was saying.
Oh, okay.
Yeah.
So, Dijkstra.
Yes, so right now we use something very simple. If you want to put in your own proprietary PCE kinds of thing, and there are vendors that have very sophisticated computation engines, so you can put that as well. But our goal is not to add value there. So we put something very simple to do that right now.
Was there a question there? Okay. So yeah, like I was saying, you could use the bandwidth calendaring application to submit the request, or you can use CLI to create, if you want to create more requests. So with this approach, what you could do is you could actually create very rich topologies. So this is what, it is difficult to have this if you don't, like we have now both packet and optical, just like in a laptop, you can carry around, and Mininet helps you orchestrate both of them, and you can simulate the behavior. You see we have some packet nodes that, Mark, you want to fire something? So you should see multiple links coming up on these nodes. So as soon as he started some random intents, so that you can see those packet links getting populated, and if you look in each of those, it will show how it's realized through the optical layer. Yeah, that's all I had. I'll hand it to Tom. Tom, I had.
Yeah, okay, that's good. That's good. We can just leave it at that. So yeah, thanks, Prasid. So I think what I really wanted to sort of summarize with is that, I'll take that. Yeah, that's good. Thanks. So we really demonstrated that, functionality, at least from, perspective of packet optical layer, how with a converged SDN, we can do much better traffic engineering operations, with ONOS, and I'm just showing this picture, intentionally at a lower level, how ONOS can not only sees the packet layer, but also could see the optical layers. Thanks to our, participants or partners from Infoblox who helped us with this link OE development. So you potentially with this approach you can have. You notice that the big topology that we showed, and lunchtime we'll be happy to show you, with much more detail since we are running out of time, how we can have this converged packet optical network in your laptop. And what you represents here, Mininet as an orchestrator, it can not only spin off more switches and more, eventually, we are working, to enhance that, with our partners, to Mininet orchestrating dynamically some of these switches and links, and being able also to tear them down and basically enable the traffic engineers to do more optimizations around them. So with that, I want to thank you and summarize that, we believe that the, packet optical, converged control of the packet optical network will truly enable the service providers to make these networks more efficient. And most importantly, it will bring more agility for being able to do different if-thens, else's, with programming the network much faster. Thanks.